I've always just liked space. Rather than seeing it as daunting, I see exciting. What could be out there? I mean, there's so much that we don't know, like say like the laws of physics, but really like they're like the laws of physics as we know them. What is life? I mean, it's life as we know it. That to me is what's most fascinating about it. My name is Shannon. I'm a freshman at Princeton. I'm planning to major in mechanical and aerospace engineering, and I'm from Virginia.
CubeSats were invented about 20 years ago by Cal State, San Luis Obispo, and Stanford. But they turned out to be pretty difficult projects, maybe more so than the original inventors expected. All of the challenges that you have with a large spacecraft are still there to some degree with a small spacecraft. So it's really one of the hardest projects that humans undertake is the design of an autonomous on-orbit spacecraft.
I actually found out about the project through an interest meeting for the Rocketry Club. You know, you get to launch a satellite payload that's going to be launched like during a resupply to the space station. I had done like a lot of camps where we designed like theoretical space missions before, and so the idea of being able to actually launch something that goes into space was really cool to me, and so I immediately was like, I really want to do this.
I'm setting up our small spacecraft design lab with a strong focus on enabling our students to make every piece of the spacecraft in-house here, to see something actually get built and get launched during their undergrad tenure. You know, before they graduate, they can see a small spacecraft through from conceptual design, through preliminary design review, through detailed design, integration, build, fabrication, all the way through spacecraft qualification tests, integration for launch, and then finally just orbital launch from the launch site.
I think it's pretty exciting because a lot of times if we didn't have something like the VOLTERA V-One, if we didn't have the PCB mill, we would maybe get to design the circuit, but then we just send it off to a company. And I don't think I would have fully really understood what goes into a circuit, but now being able to actually see that like this is like this place where the electronics go, like using it actually helped me a lot to understand like what goes into a circuit and what components go where and all that stuff. So I think it's really beneficial to be able to see, will this stuff work in space? Because if it does, then that will be like a really great way for all these universities and even high schools that do make ThinSat and CubeSat payloads to be able to use them. When I came in and was deciding between majors, working on this project really made me want to decide officially on doing aerospace.